Hey guys, welcome again to the Maths Club. Today we'll be treating the concluding video on indices. We'll be looking at past questions on indices and standard form from 2014 to 2023 WAEC questions. Let's get started. So the first question says simplify 2 raised to the power of 5x divided by 2 raised to the power of x equal to the fifth root of 2 raised to the power of 10. So we know that whenever they have the same base and it's division that is separating both of them, we can subtract the powers, right? So this is like saying 2 raised to the power of 5x minus x is equal to, now from the laws of indices 2, we know that this is something as saying 2 raised to the power of 10 raised to the power of what? This square root of 5 can be written as what? 1 over 5, right? Great. So it's like saying 2 raised to the power of 5x minus x, that is 4x, is equal to 2 raised to the power of, I'll multiply the powers, so that will be 10 times 1 over 5. 5 here 1, 5 here 2. So 2 raised to the power of 4x is equal to 2 raised to the power of 2. And we know that by comparison, right, we can compare the powers since they have the same base and they are equal to. These are some of the things that we've actually discussed in the previous videos. So I can compare the powers and say 4x is equal to 2. So if I want to find x, I'll divide both sides by 4. Right, so 4 will cancel here, 4 will cancel here, 2 here 1, 2 here 2. So therefore, our x is equal to 1 over 2. Let's see if we are correct. So that will be option C. Great. So this question says simplify 16 divided by 9 raised to the power of minus 3 over 2 times 16 raised to the power of minus 3 over 4, all raised to the power of 1 over 3. So to solve this question, I'm going to break it into its component parts. We'll solve this part first, this part, then we'll take the cube root of all of them, right? So this is like saying, if I want to break this part, it is like saying, because there's a minus here, I can take the inverse of whatever is inside. This is like saying 9 over 16 raised to the power of 3 over 2, right? And this is like saying 9 over 16 raised to the power of 1 over 2 all cubed, right? So this is like, if I want to, I would like say square root of 9 over 16 all cubed. These are all applications of the laws of indices that we treated in the previous videos. So square root of 9 over 16, so square root of 9 is 3, square root of 16 is 4. So this is 3 over 4 all cubed. If I resolve this particular guy, and if I resolve this other guy here, because there's a minus here, I could say 1 over 16 raised to the power of 3 over 4. Also too, I could say 1 over 16 raised to the power of 1 over 4 all cubed. So if I want to resolve this is like saying take the fourth root of 1 over 16 all cubed. Fourth root of 1 over 16 is 1 over 2. Right, if you take the fourth root of 1 over 16, you have 1 over 2, because 2 times 2 times 2 times 2 will give you 16, and 1 times 1 times 1 times 1 will give you 1, right? And if I cube this guy, this is what I'll have. So if I replace it now, I could say 3 over 4 all cubed, this replacing this guy, multiplied by 1 over 2 all cubed, and I think there's a 1 over 3 on top. Yes, so there's a 1 over 3, right? I could do something else, but let's do it the right way. So let's say take the cube roots of 3 over 4 all cubed and 1 over 2 all cubed. Because this is the cube root of cube times cube, of course it just goes to be the value. So this will just be 3 over 4 times 1 over 2. And if you do the multiplication, you're going to have 3 over 8. So this is actually the solution for this particular thing. This is more like an application of all of the things that we've been doing on indices, especially the laws of indices. So that is option C. Great. Now let's look at this other question. It says evaluate 0.064 raised to the power of minus 1 over 3. Now, first thing is that we have to convert our decimal here to a fraction. Remember what we said about it. So I'll just say 0.064. I'll divide it by 1, right? Then multiply both the bottom and the top by 10 raised to the power of the number of digits after the dot. So the number of digits is 1, 2, 3. So times 3 raised to the power of 3, and that's like 1000 over 1 times 1000. So minus 1 over 3. If I multiply this guy by this guy, this will just give me 64 over 1000 raised to the power of minus 1 over 3. Because of the minus here, I have to invert this guy. That will be 1000 over 64 raised to the power of 1 over 3. And this is like saying take the cube root of this particular guy. If I want to take the cube root of this guy, what would that give me? So that will be cube root of 1000 over 64. Cube root of 1000 is actually 10, and the cube root of 64 is actually 4. So if I divide both sides, this will be 2 and this will be 5. So our answer will actually be 5 over 2. If that is how they put it, so that will be 5 over 2, and that's option A. Great. Now the next question is saying if 0.25 raised to the power of y is equal to 32, find the power of y. Now for us to do this, we have to first resolve this to a fraction, right? Based on what we said divide it by 1, then multiply both the top and bottom by 10 raised to the power of the number of digits after the dot. So that is 10 raised to the power of 2, or 100. So this will be 25 over 100, right? So that will be 25 over 100 raised to the power of y is equal to 32. So 25 over 100, how can I divide this further? I could say 1 and 4, right? So this is like saying 1 over 4 raised to the power of y is equal to 32. Or I could also say 4 raised to the power of minus 1 raised to the power of y is equal to 32, right? And 4 raised to the power of minus 1 is saying 2 raised to the power of 2 minus 1 y, right, is equal to 32. If you look at 32, 2 times, that's 2 raised to the power of 5. So what I did, I said let this 4 be 2 squared minus 1, then our y. So I could expand the bracket and say 2 times minus 1 is minus 2 times y is minus 2y is equal to 2 raised to the power of 5. Then by comparison, I could say minus 2y is equal to 5. Therefore our y will be equal to what? 5 divided by minus 2, or minus 5 over 2. So I know that this place can be a bit confusing, but all I just did, I said 1 over 4 is simply saying 4 to the power minus 1, and 4 is simply saying 2 squared. So I just place this 4 with 2 squared and the bracket the minus 1 and then the y. So I multiplied all the powers, 2 times minus 1 times y, to give me minus 2y, and I did comparison. So we found our y to be equal to minus 5 over 2. Right, that's option A. Great. So this question says evaluate 0.42 divided by 2.5 divided by 0.5 times 2.05 and leave your answer in standard form. So this is an objective question. So because an objective question, it's just best that you use a calculator to be able to answer this. So if I switch over to, this is what we have, right? So if I use this calculator to find what the value will give me, so that will be 0.42 divided by 2.5. This gives me 0.168. So let me just write that down. Then the bottom, so you have 0.5 times 2.05. So please do it like this. If you're going to be using the y calculator, right, do it like this so that you ensure that you're not going to have any mistake. If you do everything together, there's a probability that you might make a mistake. So 0.168 divided by 1.025. This gives us 0.1639. So we can just say this is equal to 0.1639. So if I wanted to convert this to standard form, right, I'll just move this one bit. So that will be 1.639 times 10 raised to the power of what? Minus 1, because we're going in the other direction. Right. So let's see if our answer is correct. 1.639 times 10 raised to the power of minus 1. That will be option C. Great. Now this next question says that given that C is equal to 2 raised to the power of minus x, find 2 raised to the power of x plus 1 in terms of t. So let's see this question. So we're given t is equal to, I want to find this in terms of c. So how can we express this 2x plus 1? We could express this 2x plus 1 as 2 raised to the power of x times 2 raised to the power of 1, right? Based on what we've done before. And we can also express this t to be equal to, because this 2 raised to the power of minus, we can say 1 over 2 raised to the power of x. So I can cross multiply and say t times 2 raised to the power of x is equal to 1. So 2 raised to the power of x is equal to 1 over t, right? And then because I know that 2 raised to the power of x is equal to 1 over t, I can substitute it inside this guy here and say this will now be equal to 1 over t times 2 raised to the power of 1 is 2. So this, and 1 over t times 2 is 2 over t. So this is actually it. What we did is that we broke this down into, is based on the laws of indices. Then we express this onto based on laws of indices. I will make the 2 raised to the power of x subject to formula and then we replaced. So our answer should be 2 over t. That's option A. Great. Now this next question says that we should simplify 3 raised to the power of n minus 1 times 27 raised to the power of n plus 1 all over 81 raised to the power of n. So to solve this question, we're going to express all of them in terms of 3. So 27 is 3 raised to the power of 3. 81 is 3 raised to the power of 4. Right, you can always check all of this. So we can replace, that will be 3 raised to the power of n minus 1 times 3 raised to the power of 3, open bracket, n plus 1. Right, I just placed 27 3 raised to the power of 3 all over 3 raised to the power of 4 raised to the power of n, because 81 is 3 raised to the power of 4. 3 raised to the power of n minus 1 times 3 raised to the power of, expand this bracket, that will be 3n plus 3 all over 3 raised to the power of 4 times n, 4n. Based on the laws of indices, because they have the same base, I can, and it's multiplication that is joining them, I can add the powers. So that will be 3 raised to the power of n minus 1 plus 3n plus 3 all over 3 raised to the power of 4n. So let's simplify. This 3 raised to the power of n plus 3n, that is 4n, minus 1 plus 3, that is plus 2, right, all over 3 raised to the power of 4n. Right. And also based on the laws of indices, what can I also say from here? I could also say that this can be written as 3 raised to the power of 4n times 3 raised to the power of 2. Right, I'm just breaking up this all over 3 raised to the power of 4n. So I can cancel out. Since it's multiplication that is here and it's division, I mean, I could just cancel out. So this will remain only 3 raised to the power of 2. And that means our answer is what? Is 9. Because 3 raised to the power of 2 is 9. So that is option B. Great. Now this question says that without using mathematical table or calculators, evaluate 0.09 times 1.21 all over 3.3 times 0.00025 and leave your answer in standard form. You see this type of questions in the theory of WAEC. So let's go. So the first thing is that let's express all of this in terms of standard form, right? So this will be 9 times what? 1, 2 times 10 raised to the power of minus 2 times 1.21. I always leave it in terms of the whole number portion, so I'll just move it back 2 times. That will be 121 times 10 raised to the power of minus 2. Why I say leave it in the whole number portion is easier to divide when it's whole number or multiply when it's whole number than when it's 1.21 times 10 raised to the power of 0 or something like that. So divided by 3.3, I'll leave it in terms of the whole numbers. That's 33 times 10 raised to the power of minus 1, right, times 25 times 10 raised to the power of what? This is 1, 2, 3, 4, 5 minus 5. If any of these things we're doing is strange, please check the place in the description. We've built up to this particular point. We started from laws of indices, we read the standard form before we now enter this WAEC solution. So let's simplify. 3 here 3, 3 here 11. 11 and 1, 2, 1. Since multiplication, I can divide. So 11 here 1, 11 here 11. Right. What else do we have? I think that's it. So 3 times 11, that is 33, times 10 raised to the power of this, 10 raised to the power of 10 raised to the power, so that will be minus 2. Then because of multiplication, that will be plus minus 2, which is like something that say minus 2. All over 1 times 10 raised to the power of minus 1, or 1 times 25 is 25. Right, so that I don't start doing something that would be very distant. Let me just correct that. So that will be 25 times 10 to the power of minus 1 plus minus 5. That will be plus times minus is minus. That will be minus 5. So this is 33 times 10 to the power of minus 4 all over 25 times 10 to the power of minus 6. Minus 1 minus 5 is minus 6. Let's simplify this further and say 33 over 25 times 10 raised to the power of minus 4. This is like 10 raised to the power of minus 4 divided by 10 raised to the power of minus 6, because it's division, right? And they have the same base. That will be minus 6. Right, so this 33 over 25 times 10 raised to the power of minus 4. Minus as minus is plus 6. Great. So this is 33 over 25 times 10 raised to the power of minus 4 plus 6 is actually 2. You are owing somebody 4 naira and you pay the person 6 naira. The person is going to give you a change of 2 naira. So this one, so we can also simplify. We know that I can say 1 over 25 times 33 times 10 raised to the power of minus 2. 1 over 25, I can find that easily, right? Because I know that 100 divided by 25 is 4. So for me to get the 100, I need to have 2 zeros. That would be 0.04, right? Because 25 times 4 is 100. So times 33 times 10 raised to the power of minus 2. I can write 0.04 in terms of standard form. That would be 4 times what? 10 raised to the power of minus 2. Great. Times 33 times 10 raised to the power of minus 2. So I can group and say 33 times 4 times 10 raised to the power of minus 2. 10 raised to the power of minus 2, 10 raised to the power of minus 2. Multiplication, that would be plus minus 2. So that would be minus 2. Right? Plus times minus is minus. So 33 times 4, I can find that easily. And say 2, 1, 12, 13. So that will be 132 times 10 raised to the power of... Sorry, I made a mistake somewhere. So this is not minus 2. Of course, this was plus 2. I don't know why I changed it to minus. Forgive my error. So this is plus 2 minus 2. So this would be 0, right? Just in case. So we had minus 4 plus 6. We had 2. Right, I mistakenly wrote minus, so that is a mistake on my part. So anything raised to the power of 0 is 1, so we have 132. Let's convert this 132 to standard form. I'll just move the dots here, 1, 2, so that will be 1.32 times 10 raised to the power of 2. So that should be our answer. Great. So you can see, always try to resolve. When you see like 1 over 25, 33 over 25, remember I said you should not use calculator, so you should not use calculator at all. Try and see if there's a way you can be able to break up something and find something that makes sense. Like this, we have to break up the 33 over 25 to 1 over 25 times 33. We can easily find 1 over 25. It gives us a fraction, convert that fraction to standard form, then we can easily multiply 33 by 4. Right. The next question says that if 27 raised to the power of x times 3 raised to the power of 1 minus x over 9 raised to the power of 2x is equal to 1, find the value of x. So to solve this question, we're going to express all of them in powers of 3. So 27, what is 27? 27 is 3 raised to the power of 3, and 9 is 3 raised to the power of what? Of 2. Great, so let's replace. So 27, I'll just say 3 raised to the power of 3 raised to the power of x times 3 raised to the power of 1 minus x all over 9 is 3 squared, so 3 squared raised to the power of 2x is equal to 1. Right, so let me simplify. That will be 3 raised to the power of 3 times x is 3x times 3 raised to the power of 1 minus x all over 3 raised to the power of 2 times 2x, that is 4x, is equal to 1. Right, so this 3 raised to the power of 3x, since they have the same base, I can add their powers. 3x plus 1 minus x all over 3 raised to the power of 4x is equal to 1. So let's simplify. 3x minus x, that's 2x. So 3 raised to the power of 2x plus 1 all over 3 raised to the power of 4x is equal to 1. Right, so I can cross multiply now and say 3 raised to the power of 2x plus 1 is equal to 1 times 3 raised to the power of 4x is just 3 raised to the power of 4x. And by comparison, right, you write it out. By comparison, we could say 2x plus 1 is equal to 4x. Right, let me take like terms. So that would be 2x minus 4x is equal to plus 1 convert, that will be minus 1. 2x minus 4x is minus 2x is equal to minus 1. Right, and I can divide both sides by minus 2 to make x stand alone. This will cancel this, minus will cancel minus, so our x is equal to 1 over 2, and that's option B. Great. So this question says that if 2 raised to the power of n is equal to y, find 2 raised to the power of 2 plus n over 3. Great. So the first thing that we need to know is that we can break up this 2 raised to the power of 2 plus n over 3 and say this is the same thing as saying 2 raised to the power of 2 times 2 raised to the power of n over 3. Also too, we can also break up this n over 3 by saying this is the same thing as saying 2 raised to the power of 2 times 2 raised to the power of n, open bracket, 1 over 3, right? We can always break it. Now that we know that, and we know that our 2 raised to the power of n is equal to y, so I can substitute and say 2 raised to the power of 2, which is 4, times 2 raised to the power of n, which is y, raised to the power of 1 over 3. So our answer should be 4y 1 over 3. Let's see if we're correct. Yeah, so that would be option A. Great. Now the next question is saying that we should simplify square root of 8 squared times 4 raised to the power of n plus 1 all over 2 raised to the power of 2n times 16. What you notice in all of them is that you can express all of them in terms of 2. So we know first off that 8 is what? 2 raised to the power of 3. 4 is 2 raised to the power of 2. 16 is 2 raised to the power of 4. So you must know this things, right? 16 is 2 raised to the power of 4. And if you don't know, you can just do like this long table: 16, 2 in 16, 8, 2 in 8, 4, 2 in 4, 2, 2 in 2, 1. So how many 2's do you have? You have 4. So 2 raised to the power of 4. Great. Now let's substitute. That will be square root of 2 raised to the power of 3 raised to the power of 2 times 2 raised to the power of 2 raised to the power of n plus 1 all over 2 raised to the power of 2n times 2 raised to the power of 4, right? And I can simplify before I go further. That would be 2 raised to the power of 3 times 2 is 6, times 2 raised to the power of, that would be 2 raised to the power of 2n, 2 times n is 2n, 2 times 1 is 2, plus 2, all over 2 raised to the power of 2n plus 4, right? Based on the law of indices. Also, based on the law of indices, I can rewrite it and say this is 2 raised to the power of, since this is 2, this 2, this 2, so that would be 6 plus 2n plus 2. Then because this division is, there's a division that is bounded, that will be minus what? Open brackets 2n plus 4. Great. So I can resolve this. I can resolve this further and say this is equal to what? Square root of 2 raised to the power of 6 plus 2n plus 2. I'll open up this bracket and say minus 2n, because minus times 2n is minus 2n, minus times plus 4 is minus 4. Great. So we can resolve this and say this is square root of 2 raised to the power of 6 minus 4, that's 2, that's 2 raised to the power of 2. Oh, 6 plus 2, that is 8, minus 4, that is 4. So this will be 2 raised to the power of 4. Right. Minus 2, I'll be plus 2n minus 2n, that will be 0. So really, this is what we have here. We have 2 raised to the power of 4. Great. So if we have 2 raised to the power of 4, 2 raised to the power of 4 is actually 16. So that's like saying square root of 16. Right? And square root of 16 is 4. Alternatively, if you didn't want to do that, you could say 2 raised to the power of 4. By the time you take the square root, that will be 2 raised to the power of 4. You can also write it as 1 over 2, right? And you can say 2 will cancel 2 here, so that will be 2 squared. And you're left with 2 squared. And that's the same as also 4. So any way you want to do it is actually correct. So one thing that you have to take up out of this question is that always know when to put minus and plus. And when you want to put minus, always put brackets. If I said minus 2n plus 4 without the bracket, that is something entirely different. So you must always be very careful of some things like that. Let's see our answer. So our answer should be option C. Great. So this question says that without using mathematical tables or calculators, evaluate 0.6 times 32 times 0.004 over 1.2 times 0.008 times 0.16 and leave your answer in standard form. To solve this particular question, I'll first express all of them in terms of standard form. So that will be 6 times 10 raised to the power of minus 1 times 32 times 4 raised to the power 4 times 10 raised to the power of minus 3 all over 1.2 is 12 times 10 raised to the power of minus 1 times 8 times 10 raised to the power of 0.008 is times 10 raised to the power of minus 3 times 16 times 10 raised to the power of minus 2. Great. So we can now listen. So since this is multiplication, so we can be able to cancel out like that. So 16 here, 4 here 1, 4 here 4, right? 10 raised to the power of 3 will cancel 10 raised to the power of 3. 10 raised to the power of minus 1 will cancel 10 raised to the power of minus 1, right? 4 here 1, 4 here 8, 8 here 1, 8 here 1, 6 here 1, 6 here 2. So we are left with, all of these have been considered, so we are left with 1 over, so this is 2 times our 10 raised to the power of minus 2. So we can split this into 2 and say 1 over 2 times 1 over 10 raised to the power of minus 2. If I do this, 1 over 10 raised to the power of minus 2 is like saying 1 over 2 times 10 raised to the power of minus 2 raised to the power of what? Of minus 1. Great. So 1 divided by 2 is 0.5 times 10 raised to the power of minus 2 times minus 1. That will give me minus as minus is plus. 2 times 1 is 2. Great. Is this in standard form? The standard form? No. Right? It has to be a number between 1 and less than 10. So this is 0.5. So I need to move this back one time. So that will be 5.0 times 10 raised to the power of 2. Then I move the 1 back. So that will be minus 1. So that will be 5 times 10 raised to the power of 1. Right. So that's it. Alternatively, if I did not want to do it like exactly I've said, this is 5 times 10 raised to the power of minus 1 times 10 raised to the power of 2. Now use the law of indices and say minus 1 plus 2. Any way you want to do it is correct. So our final answer is 5 times 10 raised to the power of 1. So with this, we've actually come to the end of WAEC questions on indices, and we're closing the chapter on indices and standard form.